All right, let's talk about something in software development that sounds like it's straight out of a spy movie. Environment secrets. So, what are they really? Well, it's all about one critical thing: how you protect the most sensitive, most important parts of your application. Just think about it for a second. Your app probably needs to connect to all sorts of things, right? Mapping services, payment gateways, databases, you name it. But it can't just walk up and ask for data. It has to show some ID, some kind of credentials to prove it's allowed in. So how does it actually do that? Well, it does it with special digital keys. And that's going to be our main metaphor for this whole explainer. It's simple, really. Just like you need a physical key to get into your house, your app needs these digital keys to unlock all the different services it depends on. So these digital keys we're talking about, in the developer world, these are what we call secrets. Let's dive in and break down exactly what that means. A development environment secret is basically any sensitive piece of information your app needs to do its job. We're talking about things like an API key, a database password, or a special access token. And here's the absolute number one most important rule. That information has to be kept private and stored completely separate from your code. Because if you don't keep them separate, well, you've got a massive open door problem. Let's talk about the absolute nightmare scenario that can happen when these digital keys get into the wrong hands. If a secret gets exposed, things can get bad fast. Someone could use your accounts and start racking up huge bills on cloud services. Or they could steal or even corrupt your user data, which is a massive breach of trust. In a worst-case scenario, they could disrupt or even completely take down your application. You know, this quote just hits the nail on the head. Committing a secret directly into your code is literally the digital version of leaving your house keys under the doormat. You just wouldn't do it with your real keys, so there's no way you should do it with your digital ones. And it's such an easy mistake to make. In the careless example, the API key is just sitting there, written right into the code for anyone to see. That's a huge security risk. But the secure method is different. The code doesn't contain the key itself. It just references a variable that securely pulls the key from a completely separate, safe location. Okay, so that's the problem. How do we actually create that safe place? Well, let's take a look inside what you could call a modern digital vault built for exactly this kind of thing: GitHub Codespaces. The easiest way to wrap your head around Codespaces is to just think of it as your own personal, high-security coding computer that happens to live in the cloud. It's a fresh, clean, controlled environment for every single project you work on. And it's secure by design right out of the box. Each codespace is totally isolated in its own virtual machine and private network. It's like having your own locked office. It uses temporary tokens, kind of like security badges that expire, for access to GitHub. And by default, all the doors are locked, firewalls are up, blocking any unwanted connections. So the vault is secure, which is great. But how do we actually use our secret stash of digital keys? Let's walk through how it all works in practice. The process is actually pretty straightforward. First, you store your secret safely inside your GitHub account settings. Remember, never in your code. Next, you just give it a unique name and then grant access only to the specific projects or repositories that actually need it. Then, whenever you start up your code space, GitHub automatically and securely makes that secret available for your code to use. So how does that magic work? It's done using something called an environment variable. And honestly, the best way to picture this is like a temporary digital sticky note that's attached to your cloud computer. Only your application can read what's on the notes, and because it's separate, the secret itself never gets written into your permanent code files. It's a pretty clever system. Okay, so you get the mechanics. Now let's get to maybe the most important part: the golden rules. These are the best practices you need to follow to be a really responsible digital keymaker. There are a few really important things to keep in mind here. First, secrets only get loaded when you create or restart a code space. So if you change one, you'll need to do a quick restart. Second, and this is a big one for security, your secrets are not available during the initial build phase. This is to prevent them from accidentally being leaked into public system logs. And finally, for extra protection, if you don't have write access to a project, your secrets won't get injected at all. Period. And all of this leads to what is without a doubt the single most important rule of all. Because your environment has access to your digital keys, you have to only open and work inside of repositories that you absolutely know and trust. Opening a malicious repository could potentially expose everything. And that idea of trust has to go beyond just your own code. You also have to think about your dependencies, all those third-party packages your code relies on, and any extensions you install. These are all tools running in your environment. So you have to be sure they come from reputable sources so you don't accidentally invite a new risk in. So here's the big takeaway. Securing your digital keys is the first most important step. But it leaves us with one last provocative question to think about on your security journey. Your code is secure, but are your dependencies?